Hello everyone, and I am logged on. So today, hello everyone, hello. So today I'm going to do a Scientist Mel shorts. That's me in my shorts, my Wonder Woman shorts. Hello everyone. If you have the Periscope app, you can hop on and interact with me there, and I'm able to see your questions and answer them right away. So that's kind of helpful, and that's why I like to do little things like this. Now this particular one, the Scientist Mel shorts, tend to be a bit shorter in length than my standard The Science Of shows. And since I get asked about certain things so often, I do my Scientist Mel shorts so that I have a reference so people can go back and see a video that has a bit more information about a particular topic. I've done it on science education, I've done it on how to teach evolution, I've done it on the scientific method and law, theory, hypothesis, all of that. Now we're going to do it on peer review. So this is a peer review edition. So what I want to show you, alright, so here we go. I have several sources that I'm using for peer review in regards to this. Now, this particular one, and I can link you to these sources. If you look down at the bottom of my slides, I will have links to various sources you can look up on your own if you want additional information. So what essentially is peer review? Peer review is the evaluation of scientific work by others working in the same field. So that's kind of the short definition. But there's a lot that's involved in peer review that a lot of people don't necessarily understand. And so they're like, okay, so some people look at it, so what? It's a bit more detailed than that. And it's quite like, as a scientist, sometimes people want to rip their hair out over it. So let's talk a little bit about that. Oh, they pay every paper author, yeah, so it's interesting. It's interesting nonetheless. So here I have a picture, and I'm going to blow this up here in just a second so you can see it a bit better than this, but the basic process for peer review. So let me switch over to that screen, and then we're going to take a look at this. Here we go. It'll pop up in a second. So what I want you to look at here for this particular one, this is idea. Basically you have an idea that you put into place, or you're testing a theory, or you have a hypothesis for something, and then you go ahead and you do all of your experiments with your researching. Then you start writing your paper. Then once you get your paper all together, you got your manuscript, you're going to send it to a particular journal editor. Hello everyone. And then that particular editor is going to send it to 3 to 5 experts in the field. They're going to look through that data, they're going to look through your paper, and they'll either say, yes, this is great, we're going to accept it as is, which almost never happens, or they're going to say, you need to make changes here, this doesn't quite make sense, or they're just going to reject it outright. So that essentially is the basic process of peer review. So first you do all of your experimentation, then you write your paper, then you send it, and you're just like, come on guys, I showed you everything. And sometimes they're like, yeah, nah. So let's get in a bit more detail what that means. Alright, so this particular journal is a well-established journal, Elsevier, and they have their own process that they go through. Now I know you can't see this, so I'm going to blow it up again so you can see it a bit better, and then I'm going to go through briefly what happens at each stage. Now again, if you want to look up this type of information, you can go to the links that I have at the bottom, or ask me on Twitter and I'll send you the links directly that way. So let's go to the next screen, and I'm gonna shrink myself down a bit someday. Alright, so when this pops up, here we go. So the first one we have at the top here, you have done all this work and you go and you submit it to the journal. There it is. Then it has to undergo some basic criteria. I'm using my little mouse here. I hope you guys can see it. And the basic criteria is, do you have the correct references? Do you have a basic understanding of the science that you're doing? If not, nah, it gets sent back to you and it's rejected outright. All right, so that's just the basic criteria. The next goes to this first screening, which is the chief editor of the journal. All right, and he looks it over, he or she looks it over, and they send it to a couple of reviewers. Now, these reviewers are going to be scientists in the same field, which means this person probably is doing research in the same field, and here's another person. They're going to go through it. They're going to rip it apart. They're going to see if you can actually, if your conclusions match your data, and if so, they're like, all right, this is great. Let's send it to the chief editor. And he or she is going to send it to additional reviewers. If not, they may go as far as another reviewer and have them check it out. So this chief editor is going to send it to a couple other reviewers. So far we've got 4 different people. I didn't mean for it to go back there. Guess you guys are, let me switch back to here. Sorry. So we've got about 4 people. I clicked when I shouldn't have clicked. See, we can mess up. All right, so far we've had 4 reviewers go through this. All right, and so after these 4 reviewers, they go through, they pick it apart, they look for proper English grammar, language. Is it easily understandable? You know, can we follow with what they're trying to say? And so after they've gone through this review process, then it goes back to the author, because it never gets accepted on the first run around. And so this author then has to take everything these reviewers said that is wrong with the paper, possibly even re-experiment and redo some experiments because they want to make sure the data is concrete. Then they send it in for a second review. All right, we're at the bottom orange circle here. Then they send it in for a second review after it's been through all this screening. You have 4 reviewers looking at it again, double checking, making sure they're satisfied with any changes that needed to be made, if there's any additional data that needs to be provided, and as well as explanations as to why they have certain data that might be indicative of something else. So they have to, essentially the author has to be able to defend every single piece of data that is in that paper to the liking of these reviewers and the editor. So if it's rejected outright, they send it right back to you and they're like, yeah, no, sorry. If it's accepted for publication, then it goes for an editorial board meeting. And then they sit around and talk about it. And then they're like, all right, let's publish this junk. And there you go. You end up in a brand new article in your well-established journal. Now, the more prestigious the journal, the more rigorous the peer review. That is a rigorous peer review that we saw there. But that's customarily what happens. But there's various types of peer review. So we're going to talk about the individual types that we have, because there's not just one, there's not just, you know, that particular thing. You might have people that know each other. So depending on the journal that you submit your manuscript to, you have 3 types of well-established peer review. You have single blind, you have double blind, and you have open. Single blind means the reviewers are anonymous, but they know who the author is. All right? You don't know who's reading your work. You don't know what their review comments are going to be. You don't know who's checking it out. But this is the most common form of peer review. Now, this reviewer anonymity allows impartial decisions to be made by those reviewers. There are some concerns by authors, though, especially since these reviewers are experts in the field and they have research in that field. Some authors may have some concerns that this reviewer might delay their publication in order to get their paper done first. See, in academia, second place wins you nothing. You have to be first publication. We know this. You know, we've seen the Watson and Crick story. They were published first, but they used Rosalind Franklin's data. She was published second, but she's the one who discovered this helical structure of DNA, and they took her data and they used it and they published first. This is still a thing that happens now. And so some authors have concerns. Yeah, I know, that's a sad face kind of thing. So some authors have concerns that what if I've come up with this brand new thing and this expert in the field takes it and they're doing the same research and they've come up with the same brand new thing that I have. So that's a problem that can come with single blind, all right? But it's the most common form. Double blind. The authors don't know who the reviewers are, and the reviewers don't know who the authors are, all right? So I will say also with the single blind, jumping back a bit, sometimes the reviewers can be overly harsh and really kind of mean, especially if they know who the author is, and so they use their anonymity to be overly critical. So that's one thing that can happen in regards to single blind. Now let's hop to double blind. Okay, double blind means that the authors don't know who the reviewers are and the reviewers don't know who the authors are, all right? And so since the reviewers don't know who the author is, this allows some bias to be removed. It sounds like social media. Yes, to a degree. It does sound a little bit like social media. And so since you have this anonymity on both sides, another upside to not knowing who the author is, let's say Stephen Hawking makes a new discovery in a lab or something, and he's still doing research and he manages to make this discovery, you know. A journal gets a Stephen Hawking article. They'll be like, oh my gosh, this is Stephen Hawking. He's doing research and he's doing this again. It sounds amazing. You know, they might not look at the content so hard. And so the focus is more on the content and less on the prestige of the author. So that's another thing where double blind is kind of useful in that regard. You're not starstruck over the awesomeness of the author and you're focused more on the content. All right, so the downside though to kind of double blind is reviewers at some point, if it's the same journal or at least the same people in the field that you're in, hello, if they're in the same field that you're in, at some point they'll be like, you know what, this sounds like scientist Mel's work. They kind of like start to notice, okay, they write this way. This is what she's doing, you know, this is her field. This looks like her stuff, you know, and she got self-citations. It's the same subject matter. It's the same writing style. So at some point, reviewers are going to know who you are. So that's kind of where the double blind might fail in that regard. And then the last one is open review, where everybody knows everybody. You're like, hey, it's Dr. Bob and it's Dr. Sally and we got Scientist Mel and we all know each other. And so that is for some. You have a question? I was wondering if they can recognize you. They probably can. You know, at some point they're gonna be able to. I mean, they're gonna be able to. You can't like you develop a writing style at some point. It's almost like the handwriting thing. You know, they're gonna know it's you. So in an open review, everybody knows who they are, which is, you know, I suppose that's a good thing. And some believe that this is the best way to prevent malicious comments, plagiarism, and pushing of agendas. Like, well, you know, if I know it's this person and they know it's me, then I can't delay their publication, and, you know, because I'm doing the research. So it kind of eliminates a bit of that. Some feel it encourages open and honest reviewing. But at the same time, some people see it as a less honest process. So where, you know, people are considering manners and politeness over actually reviewing the work. A high school science teacher told me some prestigious scientists could skip peer review. Any truth to that? I wouldn't think so. I wouldn't think so. Especially when you, I have to say, there's got to be a little bit of an ego thing there to be able to go through a particular piece of work. If you're going to be the peer review on a Stephen Hawking paper or on a Professor Brian Cox paper or on a Neil deGrasse Tyson paper or whatever, you want to be the person that's like, yeah, no, I don't think so. You did this wrong. you know, you need to check this again. But, you know, and if you have anonymity and they don't know who you are, you're going to be able to do that a bit more. You want to be the person that's like, okay, but actually, you know, you need to work a bit and go back to the drawing board on this one. Consider this option. So if you're the person that catches the error, you know, this was a problem in the religious age. It got people killed. It kind of did, yeah. There's a lot of problems associated with that, being able to take criticism. You know, this, you've gone all professional on scope. So what happens with this, when we were looking at this, let me hop over to, let's see, the next one we're going to talk about. We're almost finished, and so, all right. So let's talk about the last few things in regards to peer review, all right? The important things associated with it. All right, so first of all, articles can be transferred. So if your manuscript gets rejected, it doesn't necessarily mean that it's, you know, you can never, they might just send it to another journal that they publish. So that happens often. You might be saying, okay, I want to get in the Journal of American Chemistry Society. I need to totally get into this. I want to do this. And you're like, this isn't quite what we're looking for this journal, but we have another one that it'll work with. That's a bit more specialized. So even if it gets rejected from a particular journal, that doesn't mean that they're not gonna, you know, transfer it over for free, you know, because you usually pay for peer review. I don't think people realize that. You hate it when you work on something for a whole year and it gets rejected, though. Yes, that does suck. So the way you're doing that is they might say, okay, this isn't appropriate for this journal here, but we can send it to this other journal and it'll be okay. It should be fine. You won't have to go through all the same peer review that you went before. If you meet the criteria that the reviewers want you to meet, then they'll go back through and say, okay, yeah, they explained this, they clarified this, they fixed that grammatical error. Good. Ugh. They fixed that. They fixed this over here. This is appropriate for this journal. All right. It is heavy scrutiny. As I've shown you, it's no cakewalk. You don't send in your manuscript, give them your money, and we're like, okay, I paid up for this. You guys are going to accept it now. No, they may not. They'll take your money and send it right back to you if they think it's terrible. So that's the reality of that. The authors must defend the data. This holds the authors accountable for their data, and they have to be able to show how they got it, why they got this data, all of this information. What software are you using for this video? I am using OBS, OBS associated, and I'm doing PowerPoint as well. I've done fancy things now. I've fancied it up a little bit, and I like this format. I think this is pretty good. So, and since authors have to defend their data, they have to not be thin-skinned. You have to be able to take criticism and say, you know what, I don't believe your data here. You need to go back and perform this experiment in addition to this to prove that this is accurate, and that can happen. So they may make you go back and show additional data to reinforce the data that you have and for your conclusions. What's an average peer review price? Or they're all very different, and I haven't had to pay them as a grad student. Normally your advisor would pay that, or the department. So before you would ever send anything off, as a graduate student, your advisor would go through everything, and likely you would probably have a few other friends take a look at it as well before you send it for the initial review. Funding is very cutthroat, and it rides heavily on publications, and so the scientists who get published in the more prestigious journals, you have a point system that's doled out with various journals that can go anywhere from 1 to like 10. All right, So if a journal has like a 10-point journal, that means if you're published in that journal, you'll have at least 10 citations in other people's papers from that one publication. And so that's an example. There's probably, I think it goes much higher than that. I haven't had to look at it in a while, so apologies. It goes way much higher than that, I imagine. But that's an example. If you have like a 10-point journal, then that means your paper will be cited at least 10 times in somebody else's. You gotta go. Well, that's cool. And so I'm wrapping up here because I'm going a bit longer than I anticipated. Retraction. So a lot of people are like, well, falsified data and all that. If your publication is retracted, this is lethal to your career. We know this because we look at Andrew Wakefield. He published any falsified data in that publication about linking autism to vaccines. It was lethal to his career. They took away his license to practice medicine. He left his own country. Nobody would hire him there. He has to write fake books to get money now. Conspiracy theorists love retractions. Right. But it's not common. Retractions are not very common. But there is a push again for publication, and so you have to make, that's why peer review is so important, because you have to have other experts that are looking at it. And if you're going to try to fool somebody, you're going to have to fool experts. And if you manage to fool them and you get published in a paper, nobody will ever hire you again because you're a liar. So that leads me to falsifying data means jail. Because if you've got funding from the government or from other sources, even private funding, if you show and if you get more funding on fake data, they can sue you for fraud. If it's the government, that's considered grand theft. Depending on how much money, it's considered fraudulent. You could spend time in jail. There's a person serving time right now for falsifying data on an HIV vaccine. This is real. Scientists go to jail if they lie, especially if they're funded through the government. They will come after you. So, got to bear that in mind. We're like, these scientists lie. Peer review, man. Peer review is pretty rough, and high-quality journals are rigorous. They're going to run you through the gauntlet and just rip you a new one, trying to get you to fix any kind of data. So, essentially, that's what I got for peer review. It is vital for scientific progress. We cannot have just anything getting willy-nilly published. It has to hold up to standards. Thank you for the emoji applause. And it holds scientists accountable. Not only does it hold the authors accountable for their data and their work and their experimentation, the reviewers are held accountable as well, as is the journal. The buck doesn't just stop with the authors. If that makes it to publication, those high-end journals that have a heavy, citation rate, they're not going to want something fake in their journal, because then that discredits them. And this data that's presented is verified by experts in the field. They use reviewers that know what they're talking about and are heavily published anyway. So, that's what I've got for peer review. And as always, I thank my Patreon patrons, Tony, an anonymous person, Jen, Carl, and Patrick. They help me out a lot, and I'm able to give them things on my Patreon account. And if you want to hop aboard, you can check it out there. You're welcome. So, here's where you can find me, and I am working on an audio podcast. You're welcome. I'm so glad you guys could hop on here. This is like Sunday. And you can find me at all of these places. I'm on all over social media. The only weird one is YouTube, and I post my videos there as well. So if you don't have Periscope, you can look at YouTube. Hi from SoCal. Hello. And then I'm also on Facebook. I'm not as active on Facebook. Facebookers are a bit different than Twitterers and Periscopies and all of the other folks. So, but I do have a website that I'm working on right now, scientistmail.com, to where I can just collaborate all of this on there, and that'll be easier. But I want to thank you guys for coming out. This was a lot of fun. I'm going to double check on the point system in regards to journals. I haven't had to look at that in a while, but I will verify that and get back with you guys on that because I don't want to give you incorrect information. So, well, that was fun. I hope you guys have an awesome Sunday, and I will see you on Twitter. If you have any questions, hit me up there. Okay? Thanks again. Bye.